Hello students, in this video we'll define how to compute a limit of a function of one real variable. Let's suppose that f maps e into r as a function, where here e is a subset of the real numbers, so it's a function of a single variable, and let a be a limit point of e. So that's going to be a limit point of e. So that's, of course, a limit point of the set e. Then we say that the limit as x approaches this limit point a of f of x is equal to L if for every epsilon greater than 0, there is a delta greater than 0 such that the following condition is true. The condition is that 0 is less than x minus this point a, less than delta, implies that f of x minus this limit point L, f of x minus L, is less than epsilon. Okay, so it's important to realize in this definition that x itself cannot be equal to a, because that would violate this condition over here. So that's an important observation to make over here. So let's see an example of doing a calculation like this. So I claim, here's an example. We claim that the limit as x approaches 2 of, let's do a 5x plus 4. Well, we have an intuition for what this is from single variable calculus. We know that if I plug in 2 to this, we have some vague idea of continuity, that I'm going to get a 2 times 5, which would be a 10, plus 4 is 14. So I claim that this is the case, okay? And so here's what we're going to do. We're going to prove these things. We're going to use this definition by breaking this problem into 2 parts. The first thing we're going to do is we're going to do some scrap work over here. So scrap work, here's our scrap work. We'd like what? We'd like f of x minus the limit. So I'd like 5x plus 4 minus 14 to be less than epsilon. If what? I want that to be true if 0 less than x minus, in this case, 2 less than delta. So if we simplify this expression over here, what are we going to get? So if we simplify this expression, we're going to get 5x minus 10. So I'm going to have 5x minus 10. I want that to be less than epsilon. And I can factor out a 5, and I can say that x minus 2 is less than epsilon over 5. So now we see that, oh, if we let delta be epsilon over 5, our argument should work. So now let's give the formal proof using our scrap work as our basis. So what we're going to say is this. Here's our formal proof of this fact. Proof. Let's let epsilon be greater than 0. So I was given an epsilon greater than 0. I'm supposed to find a delta. So I'm going to select delta to be epsilon over 5. And let's suppose that 0 is less than x minus 2. X minus 2 is less than delta. Then, if that's the case, then 5x plus 4 minus 14 is actually equal to the absolute value of 5x minus 10, which is 5 times the absolute value of x minus 2. Now I know that x minus 2 in absolute value is less than delta, so this whole expression is strictly less than 5 times delta. So the conclusion from this statement over here is that 5x plus 4 minus 14, that's our function minus our limit, is strictly less than 5 delta, but we know that delta is epsilon over 5, so this is exactly equal to just 5 times epsilon over 5, which is exactly equal to epsilon. So what we've shown that for an arbitrary epsilon greater than 0, we can find a delta, namely epsilon over 5, such that if 0 is less than x minus 2 and absolute value is less than delta, then our function, 5x plus 4, minus the limit of 14 is less than epsilon. And that, according to the definition, shows that the limit as x goes to 2 of 5x plus 4 is equal to 14. Thank you very much.